Alright, this is the last problem from the instructional side of this packet. It says that the possible hours in daylight in a given day is a function of the days of the year in Poughkeepsie, New York. The minimum hours is equal to 9 hours, and the maximum is equal to 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? Alright, so I'd like to just sketch what this looks like for us. If we graph this function, it says that the maximum that we see would be equal to 15 hours. So there's 15 hours, and the minimum is equal to 9 hours. All right, so 9 is the minimum. So know that this function is going to cycle between 15 and 9, 15 and 9, 15 and 9. I don't know necessarily where this begins. Maybe we're going to start looking at it at a maximum, maybe a minimum, maybe a midpoint. Doesn't really matter because we could use a sine or a cosine wave to represent this function. But what they want to know is what is the amplitude. And before we can figure out the amplitude, we need that midline. Because once we have the midline, we can figure out how high and how low our function goes above and below that midline. So to find the midline, D, we usually take the max, add it to the min, and divide by 2. So if our maximum value is 15 and our minimum value is 9, we'll add those two things together and get 24. Divided by 2 is 12. So now I know that my midline is at 12. But they're not asking us for the midline, and that's why this is here. It's probably to catch us off guard. The midline is 12, but they want our amplitude. So to find amplitude, we can always take our maximum value if we want to and just subtract that midline. That'll work. Or remember, we could just take the midline and subtract our minimum value. That should also work because those distances should be exactly the same. And either of those should give us 3. So the amplitude of this function is 3.